top, you assign each pin number. There's different pins on the robot. They all stand for a different motor. The right motor is pin 12, left motor is pin 13, speaker's pin 11. Each light sensor has its own pin. Each infrared detector, the infrared detector and each infrared sensor has its own, and then as well as everything else, like the speaker. So then also low left, low right, that turns each motor on. The speed equals 3,000, so I'm setting the speed to 3,000. And the way the speed works is 1,000 is full speed backwards, 3,000 is full speed forwards, 2,000 is stop, so it's really 500 would be half speed forwards. And to show the infrared detector. So the infrared detector sent something using an if-then command, and then you backed up and turned. You can use that to navigate around obstacles.
Like for example, like if you want to gain points, you say when images collide, the pills and the doctor, like when those images collide, the pills falling on the x-axis is 0, so it disappears. Then it goes, and then all of a sudden you see another capsule drop, and it's random at 1,000. So it goes from any spot on the x-axis, and it just drops.
This is a motherboard. Okay, and if you look closely, you see all these little dark green lines.
Whoops, you just said CPU, yeah.
And also, they're all over the back. So that's everything being connected to everything. And I think you all already know what CPU is. It's like central processing unit, brain of the computer, everything like that. This is RAM. And that's just random access memory. And basically with this, when your computer's on and working, it is like storing things, it's auto-saving, but once you like turn the computer off, it deletes, it forgets, it deletes everything from its memory. But this is what saves it. No flash photography. So basically, this is what saves it forever. But if you break this, it's really hard to get back. But this and this are the same thing. So this is like if you want to. So that is a Mac. This was in one of the original Macintosh computers with those giant ones. And you see how it's all covered in scratches? If you get one scratch on this, everything's gone forever.
The other thing is we got to make our own game. That's a little too close. We got to make our own game, and this is a game we did. You can see we did all of the code ourselves, so it was super cool. And this is a game we did. They evolved the sea turtle. Help Bob avoid the dangerous objects and make it to the shore. So when it hits the dangerous object, the health goes down, and you can get a new. Oh, the health goes up, down, and then you hit the top. You have to avoid all the objects, and make it to the end to save your baby. On the board, we have a couple examples of code. This is how you make your help screen. Pressing 35, that key is the H key, so help. Place down for bubbles. If turtle Y equals 0, that's the edge of the screen, so it moves to a new background. And noise the sound. Here's where you load in all your images, make your welcome screen, put in text, color, font, and this is speed. The numbers, the higher numbers, higher speed. This is when images collide, when they run into each other. When stuff happens, like the Diet Coke X goes randomly on the screen, and just other stuff like that. And it was really fun because we made the whole game from scratch all by ourselves.
Okay, so
Ryan. I did robots. The first thing we talk about is the 3 laws of robotics. First, a robot can't enter a queue. Second, it must obey orders that's given to it unless it takes advantage of this law. So if I tell it to kill someone, it can't. And the last one, it must protect itself unless it runs into this one. So the problem with this, these drones that we have, like, does that break 3 laws of robotics? It kills people. But is it for the right reason? Are we trying to kill them? That's a big question. So sometimes some people will say it's good if we're trying to kill someone that we want to kill. But a lot of times we mess up. We'll get one coordinate off route and we'll kill some innocent civilian in the middle of the road. So that's one big problem. Another one, Amazon has a new device that they have for taking packages to people's front doors. Is that an invasion of privacy? We don't have it. So those are some questions. So we did the Scribbler robot, and it has infrared sensors, which can detect if there's something in front of it, lights, sound, wheels, and we use an engineer language for this. For this, we would say, we want this much energy to go to the right wheel so that it can spin a certain amount. So then we would get it so that it could move forward, move backwards, turn right, turn left. It could go forward. If it sent something, it would back up, turn right, go that way, then try again. If it runs into something, it would do the same thing. So this is the coding we use right here. So this code, it has forward, backwards, spinning, sound, lights, going right, going left. So if you plug this in right here, plug this in, and then press this play button right here. It'll load the code onto this robot. When you put it on the ground, it's exactly what it's telling you. So it's going to go forward, go backwards, turn left, now it's going to turn right, now it's going to spin in a circle, and then it's going to turn the lights on and off. And that's the basic coding. So, got any questions? Nope. Alright.
Alright, good. Cool.